Well, we're continuing our demonstration of our resonant and electrical phenomena. Just to point out a couple of things, as we've seen in the previous videos. We've got our signal generator here. We're running our signal from the power supply up to end the signal right into here. So the signal generator is running here, switching our frequency. We're running the power supply in here through a series of transistors. We're coming over here to this box here. We're processing the signal and we're outputting it to the motor. This is our regulated power supply. This is our voltmeter, which actually reads the voltage that the motor is operating at. And as will be seen in our demonstration in a moment, our power supply voltage will start out being greater than the operating voltage of the motor, but as we resonate the signal, the motor voltage will then exceed the power supply voltage, and it will continue to increase almost on an exponential level. Next, we have our wire in this demonstration, which is 44 gauge wire. It's so thin, the backdrop, you can hardly see it against my hand. I'll come in and zoom the camera up. And we'll have a close-up of the wire as much as we can. Back out a little bit so we can get our focus in. I'll show how thin the wire is with the backdrop of my hand. It's almost impossible to see the wire because it's so small. With the resonant effect, we're able to transmit a significant amount of power over a small area. Now we'll zoom out a little bit. We want to be able to take a look at our meters and our motor. As we start the voltage, we'll start out sending about 45 volts into our box. At 45 volts, we'll zoom in a little bit. We're showing about 40 volts output to the motor. So the motor at the moment is running at about 40 volts through the resonant signal. So we're running at about a 5 volt deficit. If we increase to 60 volts, we're still maintaining approximately about a 5 volt deficit, so that the motor is running at about 55 volts. Next, we'll increase the voltage to 70 volts. And we notice that at 70 volts the deficit starts decreasing, so that we're operating the motor at about a 1 volt deficit. The motor's operating about 1 volt below what the power supply is actually sending into the signal to resonate. Next, we'll increase our voltage to 80 volts. And we see now that at 80 volts, the motor is now operating at a surplus of about 6, probably close to 7 volts, 86.5, almost 87. Now we're at 87 volts. So we're running at a 7-volt surplus now. We'll increase the voltage, resonating the signal. At 90 volts, the motor's running at over 100 volts now and still climbing. 102. Slowly ticking up, 103. So now we're running at a 13-volt surplus, and so the voltage differential is slowly increasing. We'll pan over and take a look at our motor. The shaft is spinning away very, very rapidly. I'll come and place my hands behind the wires. The wires are so thin you can't even see them. All of this is operating off a 44 gauge wire. Let's see if the wire can be seen behind my hand. It's almost impossible to see the wire here. You can see the little leads coming off of the wire, but then the wire itself is quite small. Let's increase it to 100 from the power supply. Power supply output voltage is at 100 volts. The motor's now running at 120 and slowly climbing. Shaft is spinning pretty fast. Now we have a 20-volt surplus. At 105 volts, our motor is now running at over 130. So the surplus voltage is about 26, now 27 volts. The resonant frequency continues to amplify as we increase the voltage. And all the while we're running all this power through this very, very fine wire, which is behind my hand. Zoom out. We'll zoom back in. Again, the wire is right here, right in front of my hand here. the light can pick up the reflection. Now we'll turn our power down. We'll shut our system off. And this concludes this short demonstration video.